Those are, I think those are okay. All right, let's get out of your homework, please. Yeah. Are there more?
Walking in powder strokes. I know.
Be here on time. Don't you have lunch right before?
Yeah, we're working on this project because we don't have any time like after school or third hour.
So you were still awake?
Yeah, we were still down there. So we were running.
I got you.
We needed effort.
I got you. So before we start the new stuff, are there any questions from stuff we ended with last time? Anything on the packet from last time that you would like me to go through? So I think we did like everything except 7, 9, and 10, if I remember the numbers right. 7, 9, and 12. So all of those, you should be able to, you're responsible to know that stuff at this point. Are there any questions that I can help with on those? Yeah. Yeah, can you read it to me?
Yeah.
I lost my homework, sorry.
So negative, and it's x squared plus 4x plus 3 over x plus 3. Oh, it's 11. Okay.
So limit is x approaches negative 3, I'm guessing?
Yeah.
Okay. So if I plug in negative 3 right away, that's always my first look, is can I just plug in? I'm going to get 0 over 0, so that tells me I gotta do something else. So I can factor. That top becomes x plus 3x plus 1. Because like 3 times 1 gives you the 3, and 3 plus 1 gives you the 4. And then those would go away. You'd have negative x plus 1. You plug negative 3 in there. Negative 3 plus 1 is negative 2, and then don't forget that negative on the outside. So 2. Did I get it right? How does that work for you? Good? Okay. Any others? Yeah. Yeah, can you read it? Wait, the square root of x and then minus 1 separate? Okay. Okay. So I'm actually going to show you a different way to do this today. But the way we did it last time was to do the difference of two squares thing. So like if the bottom were, or just in general, if I had like x squared minus 16, I could make that x plus 4, x minus 4, right? You're taking the square root of the x squared and putting it in those two spots. You're taking the square root of the 16 and putting it in those two spots, and then just plus minus. So you're not used to seeing that here, but I could do it here. I could rewrite that bottom. So what's the square root of the first thing? Square root of x. What's the square root of the second thing? 1. So I could rewrite this as the square root of x minus 1 over the square root of x plus, or times the square root of x plus 1. But you're not really used to go. Usually you're going from something squared to something. You're not going from the something to the square root of something. You still do it. It's just kind of weird. Then these cancel. Well, you gotta have something left on the top of your fraction. So what do you put up there? You put a 1, and then I could plug in. It'll be okay. So I'd get 1/2 after I plugged in. Does that help? And like I said, I'm gonna show you a different way to do it today. So maybe that way it makes more sense. Or maybe that helps. I don't know. Whatever. Any others? Okay, let's start with that one then. Let's just do, so get your notes, we're going to do rationalizing. I'll show you how to do that problem in the other method. 8 other method. Rationalizing is basically getting rid of square roots. The square roots are often the problem that you run into. That like, okay, if the square root were here, this would be a lot easier. So okay, let's try to get rid of it. So we're gonna find the part with the square root, and we're going to multiply by the conjugate. You guys remember what a conjugate is? Like, what's the conjugate of a plus b? A minus b. What's the conjugate of a minus b? A plus b. So, it's the square root part that I'm worried about. So this, I'm going to look at that top part and be like, okay, that's got a square root there. So I'm going to multiply by the conjugate of that. So I'm going to multiply by the square root of x plus 1. If I do it to the top, I've also got to do it to the bottom. And then I'm going to multiply this out. And if you do it correctly, the square root should go away. So you're foiling. This is just the difference of two squares. We're just kind of going in reverse. So what's the square root of x times the square root of x? X. What's going to happen to the outside, which is 1 times the square root of x, and the inside, which is negative 1 times the square root of x? So they're canceled. That's why we did the conjugate, because we're creating a situation where we get like the positive and the negative of the same thing, so they go away. And then what's negative 1 times 1? Negative 1. On the bottom, I'm not going to foil. I'm just going to leave it like that, because what you'll see is almost every time that things will just start canceling at this point. And now, I didn't get rid of the square roots, there's still one there, but it's in a much better spot and I can work with it now. The x minus 1's cancel. I got to have something on the top, so I put a 1 up there. But now if I plug in 1, I won't get 0 on the bottom. So now I can do the problem. So you put a 1 there, 1 over the square root of 1 plus 1 becomes 1 half. So the same answer to the problem I just did, just kind of a different approach to get to it. Questions on that method? Did you guys go through that last year? Was that one of the things you did? Maybe. Dabbled. Are we at the point where you want to try this, or should I do another one? You guys try it. If you want me to do it, just wait. I'm going to do it eventually. Alright, so now the square root part's on the bottom. So first thing I try is plug in. You won't always get 0 over 0, but usually we do here. So I'm going to multiply by the square root of x plus 2, because that's the conjugate of the thing with the square root in it. And I'm going to work out the part with the square roots first, because that'll usually put me into like how things are going to cancel. So I'm foiling this. Same as before. Square root of x times square root of x is x. The outside and the inside, like the oi of foil, will cancel. And then that's minus 4. And then that clues me in, okay, I should probably just leave that x minus 4 there, because I'll be able to cancel it, where if I like to start distributing, the code don't cancel anymore. Those go away. Now I can plug in. Square root of 4 plus 2 is 4. Somebody had 4. Questions on that method? Can look a little different, so let's go through a couple more. These are a pain to make up, so I'll be honest, I'm just reading these off your worksheet I'm going to give you. I put extras on there for you because I knew I would steal a couple. So that. it's the same approach, it just looks a little different, so I want to run through one with you. The square root is the part that I don't want there. So to get rid of it, I'm going to rationalize or multiply by the conjugate, which is now the square root of x minus 2 plus 1. Right, this is like your a minus b multiplied by a plus b, basically. I'm going to do that square root part first because I think that'll clue me into what's going to cancel. I don't want to like distribute this top part and then later realize, oh crap, I shouldn't have known what canceled. So same thing. What's the square root of x minus 2 times the square root of x minus 2? X minus 2. And then the outside and the inside are just opposites of each other, right? That's because of how we did it. One's positive, one's negative. Those go away. And then what's negative 1 times 1? Negative 1. Well, isn't that really just x minus 3? Which will cancel with the x minus 3 that's up there. So I'm glad I did not foil that top part because I would have lost my cancel this. So now the x minus 3's go away. Now you can plug in. What's 3 minus 2? 1. What's square root of 1? 1. What's 1 plus 1? 2. Questions on that one? Remember I told you I'm supposed to wait 7 seconds to see if there's questions? I learned another thing this weekend. Instead of saying, are there questions, like, come up with 2 questions about that. But then, I was like, what if I'm such a freaking good explainer? There's just no questions. Yeah. Anything I can help with on that? Yeah, it does make sense. Alright, try this. Again, I'm stealing from your worksheet. Deal with it. Everything all right, Victor?
Yeah.
So I'm multiplying by the conjugate of the thing with the square root. So I'm looking at that top part, it's got the square root that I don't want to deal with. So I'm going to multiply by the a plus b or a minus b, the other one of whatever's there. I got to be fair, so I got to do the bottom too.
Hello.
Emily and Sophie. Davenport. You can just come get it later. Is that right? Thank you. So I'm going to FOIL the top. Square root of x plus 8 times square root of x plus 8 is x plus 8. The middle two will cancel, then what's negative 3 times 3? Negative 9. And then if you notice, isn't that just x minus 1? That'll cancel with the bottom part, so that tells me we're on the right path. So this is just x minus 1, which goes away with that. You have to have something up on top, so you put 1 there. 1 plus 8 is 9, Square root of 9 is 3. 3 plus 3 is 6. I'm going to add 1/6 for an answer. Questions? Okay. Now, complex fractions, which is just like a fraction on top of a fraction. Write this down. I like that face more like. Fractions don't like you. Fractions cannot control your emotions, only you can. You can control how you react to fractions. Alright, let's go off to the side and do like some fraction practice here. If I had 1/6 plus 1/7, what would I do? What's my common denominator? 42, right? Which you got by doing 6 times 7. Agreed? So then what you would do is we multiply this one by 6, and then therefore the top by 6. And this one by 7, and so therefore the top by 7. Right? So, like going back over here, what's the common denominator between negative 3 plus x and 3? So you multiply them together, right? I wouldn't distribute them. So I'm going to multiply this over here by 3 times negative 3 plus x over 3, no, sorry, just by that. I'm going to multiply this term over here by 3 times negative 3 plus x. And I'm going to multiply this term up here by 3 times negative 3 plus x. So there were 3 separate terms in my problem, and I'm multiplying each one of those by the common denominator that I found. Should I do that again? Like start over, or should I finish the problem? We'll do a couple more. So what did I do? I looked at the bottom. So over here, I was like, okay, if I have 1/6 plus 1/7, how do I get my common denominator? I multiply the 6 and the 7 together, right? You know, if you have 2/3 plus 4/5, what's your common denominator? 15. How'd you get that? You multiply the two bottoms together, right? So here, this was my initial problem. I had that, and that. What's my common denominator? Well, I'm going to multiply them together. Right? So I'm going to, then when I find my common denominator, I'm going to multiply all 3 things in there by that common denominator. And I can do whatever I want as long as I'm fair to everything throughout the problem. So when I do that, let's watch what happens. So in this part here, what cancels? This is like over 1. Don't the negative 3 plus x is canceled? So what's left? Not 1. The 3, right? Over here, don't the 3's cancel? So what's left? Negative 3 plus x. On top, I'm not going to distribute. Kind of the same thing as we were just talking about. If I distribute it, it becomes less obvious what will cancel. You can distribute, but I think it's easier if you don't. So I'm going to leave it like this for now. Then don't I just have an x on the bottom? And then what happens to the x? Cancel. And then you can plug in 0. Yeah, what?
Never mind, that's fine.
You okay?
Sort of. I was about to ask how you could just have x on the bottom.
So 3 minus 3 is 0.
Plus x.
So those go away, so you just have the x there.
Like I said, I said.
Yeah, but no, I just want, but that means someone else might have missed it too.
Fair enough.
So then, once the 3 minus 3's go away, you just have an x. Once you just have an x, you can do that. And now I can plug in my number that I wanted to without getting 0 over 0 and getting stuck. So now it's 3 times negative 3 plus 0. What's that? Negative 9. These are usually pretty tough for people. We'll go through certainly more than one. Where can I help on that? Yeah.
How did you get 3 minus 3 plus x on the bottom? Because wouldn't it be 3 times negative 3 plus x as a common denominator?
Well, so there's this big plus sign in the middle, though, right? So when I multiply this together, the negative 3 plus x is canceled, and the 1s don't really matter. So all that's left over here is the 3. And then there's really like a big plus sign here. And then I'm working this out. You know, like if I had this would be, if this, the common denominator here is 15, right? So I multiply by 5, I get 10 15ths. Plus whatever's over there. It wouldn't be times.
Yeah, but
Or am I talking about different spots?
so to get the common denominator, you had to multiply top and bottom. Just looking at the bottom part of the big fraction, you had to multiply.
I'm just looking at the, forget that's even up there.
Yeah.
I'm looking at the denominator here, the denominator here. And the same way that I got to 42 by multiplying those together, I'm multiplying this times this. Just those two bottoms. That becomes my common denominator.
But did you do that? I thought it looks
Yeah.
like you just multiplied by 1. Yeah.
Say that again.
She's saying on your little example, you did 6 over 6. On this one, you did just the 1 over the 3 times negative 3 plus x over 1. You didn't do the same thing over.
Okay, fair enough. That's because there's this top up here that switches whatever. So I'm not really. So maybe that was not the greatest example. It's not really the same. I was trying to get the common denominator part across, but when it's a complex fraction, it is a different. So maybe that wasn't the greatest example.
Okay, so then there's just, you mentally get that common number by multiplying it and just put that over 1 and just do the top of the.
And then, so I could do it that way, and then do it up here too, but because it's a fraction over a fraction, as long as I treat all 3 of these terms evenly or fairly, I can do whatever I want, and it's just less work to do it this way. Let's just do it on the way. You're right, maybe that wasn't the greatest example. Like I was trying to get.
I'm more than slightly lost as to how the simple fractions go to the problem. I'm just lost in general for that.
Okay.
I'd like to know.
No, I don't want to do that one yet. Talk about that one yet. Let's do that one. Do you want me to go back and explain how it's the same as the regular numbers? Or should we just forget that at this point? Just forget it this way. Kind of less. Okay, so I got this fraction on top of a fraction, right? So your common denominator is going to be, we're going to forget that the x at the bottom, we're just going to look at the top. Your common denominator is going to be the 4 plus x times the 4. See where I'm getting that from? So what I'm going to do, here, I want to do this. So we had 1 over 6 plus 1 over 7, right? What's your common denominator? 42. So we do multiply these by 42. That's going to make things worse. So we're going to multiply by, we got 3 terms. We got a term here, we got a term here, we got a term here. We're going to multiply each one of those terms by 4 times 4 plus x. Right? So this gets multiplied by 4 times 4 plus x. This gets multiplied by 4 times 4 plus x. And at the bottom gets multiplied by 4 times 4 plus x. Do you see where I'm getting the 4 times 4 plus x from? So we're just being fair to all 3 things. Multiply all 3 of them by that. So in this one here, like this top left term, after the 4 plus x is canceled, what's the only thing left? 4. That was dropping out my minus sign. In this top right term, what cancels? 4's, right? And you're left with 4 plus x. Now make sure you're subtracting the entire 4 plus x, not just like minus 4 and then put a plus x. That 4 plus x, the entire thing is being subtracted, so it's got to be in parentheses. And then on the bottom, I just have x times negative 4 times 4 plus x. I'm just going to leave that for now. Now I can see a situation where people would try to cancel these. Anybody try to cancel those? Let me ask you this. Would 8 minus 10 over 10, could I cancel the 10s and be like, okay, the answer is 8? No. So unless you're canceling from every single term in the problem, so there's still 3 terms. 1, 2, 3. You can only cancel if you're canceling from all three terms. Yeah. No, it's not, because I thought my times sign was a negative sign. Thank you. Other questions? Or other mistakes? So what's left on top? A negative x, right? Because the negative will get distributed through. The 4 minus 4 will cancel. You have a negative x over x times 4 plus 4 plus x. Now what? Look, now how many terms are in my problem? How many? So terms are separated by plus and minus signs or the giant division bar. So we used to have 3. 1 there, and 1 on the bottom. How many terms do we have now? 2. Is there anything that's in common that I can cancel out? The x's. So now there's a negative 1 on top. Now I can plug in 0, which was like the original goal in the first place, and I'll get negative 1 over 16. How many worked ahead of me and already had negative 1 over 16? Questions? Yeah.
Is it? Okay. Probably asked this way confuses me to no end. Is it possible to solve it by solving the numerator and then doing the keep change flip with the dividing by fractions?
Yep.
Okay.
I mean, work through it, make sure it works for you. But yeah.
Okay.
There are going to be times in class we want to understand this method.
How do you mean?
So there's going to be times when the keep change flip doesn't really work, and this kind of approach is necessary. So I guess I'm saying you do have to understand this. But when you say something on the top, what are you doing?
Just getting treating the numerator like the denominator is there, getting the common denominators, subtracting them, or adding them, and then putting the denominator back. So you have
Gotcha.
fraction on
Okay, then
top
you're okay.
over-
The common denominator part's the part that you really
Yeah, no, the
Okay.
common denominator I mean.
Okay.
Just be getting one fraction on top, then x on the bottom, then flipping it.
Okay.
X over 1 to 1 over x.
So I guess I'll just say try it. We'll see how that goes. So this is a little different. Your denominator here is 1, right? So what's your common denominator going to be for this one? It'll be negative 2 plus x. So I've got, how many terms do I have right now? 3. So I've got 1 there, 1 there, 1 there. I'm going to multiply each term by negative 2 plus x. So when I multiply this one by negative 2 plus x, those cancel. And I just get 1 there. When I multiply this one by negative 2 plus x, I get negative 4 plus 2x. And when I multiply the top by negative 2 plus x, I can leave it, or I can distribute. Like, just looking ahead, it's not going to cancel, so I'm going to go ahead and distribute. So I get negative 2x plus x squared. So I really have x squared minus 2x over 2x minus 3. Agree? Yes, no? I don't see what you're doing. Where we at? Mitchell says thumbs up. Do we agree with thumbs up? Dusty says thumbs up. We got 2 thumbs up. Lynn says thumbs up. Alright. Now can I plug in? And I will get 0 over 0, right? So now I can go ahead and do it. I do get 0 on top though, but is that okay? So I get 0 over 1, but that's fine. That's just 0. 0 divided by 1 is totally legitimate. That's the thing. That works. 0 divided by 0 means I'm stuck and I gotta do something else. How many got to 0 there? Okay. Questions I can help with. Like I know those are not the easiest ones. It's not a super common thing that you'll be asked to do, but it does come up. So I'm gonna go through it. Let's try this. Give me 2 questions. Come up with 2 questions for me. Yeah. So if it's a free response question, you're technically supposed to. Multiple choice, they don't care, I don't care. So in your own, like in your notebook when you're doing it, it doesn't really matter. Did you only ask that because you were forced to come up with a question, or did you actually have that question?
I wasn't sure because I know you said it with the other ones, and I thought I would like to do this as well.
It would, yeah. No other questions? Yeah. Yeah, that's the next, that's one of the next couple sections, depending what order I do it in, but yeah. Did you only ask that because we like needed the question? It's a valid question, but you're forced to move it. So here's your practice. There's a decent amount on here. 22. Trying to give you some time. If you have questions, please ask. You can walk around and help individually. Some people don't like to ask. We'll go over this tomorrow. Probably do some sort of like, we've done a whole bunch of different ways to find limits algebraically now. Some sort of like recap of all of those. And then move on. Next topic. So the one, that was just like, I was looking ahead. I was kind of choosing a little bit. I was just looking ahead up here. And I saw this, and I'm going, that's the next. And it's there, so I just have my leave so I can see the way. Down here, with the student I saw, there's the one thing for, so I kind of just have that. I switched everyone.